Hi, and welcome back. So we have gone through a couple of videos up to this point on what is data science, and there's this handy Venn diagram that I'd like you to see. As public health practitioners, you have domain knowledge in public health through your course, the many courses that you've taken in global health and health policy, let's see, health management, health systems, even some epidemiology and some psychology, other things related to and sociology related to applying the science of health to large groups of people or to an entire population. And you've also had at least a few courses, graduate courses in statistics, where you've learned some statistical methodology, maybe even some statistical theory, but probably up to this point, you haven't had much formal training in code, maybe just one course, if that. Oftentimes, you're sort of introduced to some computer code in some of these other statistics courses, or perhaps a quantitative psychology or quantitative epidemiology course. But I don't believe you've been formally introduced to computer code. Perhaps some of you have, but what we're trying to do here is we're trying to take the domain knowledge and the statistical knowledge that you've gathered so far in your graduate studies and add to it this third pillar of the computing skills. And so up to this point, your intersection of domain knowledge and statistics has yielded common research. Many of you have published papers before. Many of you have given presentations at perhaps APHA or the other conferences where you are sharing your public health research with others, and this public health research is validated by statistical hypothesis testing. However, we want to go back to the idea that we want other people to be able to build on our work, and so therefore we want reproducibility, we want replicability, and as we heard last time, we want this idea of pre-producibility. Pre-producibility being that you can take your data and your analysis scripts in whatever language you use, and you can replicate or reproduce what you did in your own paper. Now, if you can't do it yourself, if there's no way for you to rebuild the figures and tables in the manuscripts that you published, then there's certainly no way that anyone else would be able to do this. So that's kind of getting at this idea of data science is one of the tools that we can use to increase and enhance pre-producibility and therefore reproducibility and replicability in research. So we talked about the components of data science, which I'm not going to rehash here, and we gave our very first "Hello World" example. So I'll go back to the code here, and we had typed "Hello World," and we instructed the computer to tell the world hello for us. And we did this by typing in the console and pressing enter or the return key, and this executed this line of code. So I want to get into R. I'm going to take a little bit of a detour first and talk about why R is important. So if we want people to be able to take an analysis script, there are many ways that we could do our analysis in our computer such that we're writing computer code. So SAS is a very, very popular language for us to do this. In other schools and in other disciplines, you may hear about Python or Julia being languages that are important for data science. If you're familiar, if you know people that are in software engineering, you may have heard of languages like C or Java. And these are also other very important programming languages. They're less used in data science, but they are very important for what they do. They're more of these general purpose programming languages. The reason that we're going to learn R is, I think the most important reason is probably the community. When I first set out to learn computing languages, it was a daunting undertaking, to be completely honest with you. This never came easy for me. I think I failed to learn different computing languages 3 or 4 times, and I finally encountered a professor who was willing to kind of sit down with me and go through very patiently what I was wrong in my thinking to help me understand and therefore grow and become a computer programmer, become a data scientist. The R community that I have experienced has largely been incredibly welcoming to people from every stripe and shape and color. And that to me is very, very good. When trying to pick up other programming languages, sometimes the communities for those programming languages can be a little hostile. They expect you to be computer programmers, you have these computer science degrees. But we're going to be looking at R because it's a lot of the learning material in R is not actually written by computer science professors. It's written by people in medicine, by people in epidemiology, by people in business who understand that their students aren't in a school of computational engineering, but they are focused on, I'm going to go back to this idea of domain knowledge. They're getting a master's degree or a PhD in a particular domain, and they need this computing skills to help them do research, but in a reproducible and replicable way. So that's why R. Really, it's the community. And maybe in 20 years I'll be singing a different tune, but for now, the community for R is very, very healthy, very welcoming, very vibrant, and it's in my experience, it's not very often that people in the R for data science community will look down on new programmers. And this is good because you don't want to be discouraged while you're already trying to learn something. So without further ado, let's open up RStudio. So I'll show you. This is mine, and I guess I can close RStudio. So quit RStudio, and I have RStudio here. So I'll open it, and we'll see the little bouncing R, nice blue circle with R, and ta-da! This is what we see when we first open RStudio. So here, this right here, this is called the console. This is where we can type commands and our computer will interpret them. This is the environment. You can think about this as like a sandbox, if you will, where so if we're children playing with toys, we have this sandbox, this area where we're allowed to keep our toys and we're allowed to play with everything. And what's in our sandbox is available to us. And this window pane down here. This is where we can find different files on our computer. This pane is where we can build plots, or actually we would build the plots over here in the console or in another window called a script, which we'll see later. And they would appear down here. And then this is important. This is how we can find help on particular things. So this right here, this is our RStudio window, and here's an exercise for you. If you remember, we had the computer tell the world "Hello World" for us. I want you all to take a few seconds and have R greet you good morning or good afternoon whenever you're watching this, and have R greet you whatever the appropriate greeting is. So take a few seconds. I'll pause here. So you should have been able to have R or RStudio greet you whatever the appropriate greeting is. Good afternoon and good morning. So here's some basic operations. Let's see. So there's more exercises. These blue boxes right here. These are exercises for you. When you come across these, I'm gonna highlight them. I'm gonna inform you that, hey, this is an exercise. This is something that you need to do. What I want you to do, I want you to pause the video. I want you to go and open RStudio, and I want you to type along. So for instance, the last exercise, we were to say, if it was morning, we'd say, good morning, Dr. Gabriel. Okay, and so if I want to type a message, I need open quotes to start, open quotes to end, and in order to execute this line of code, I have to press enter, and that will give me the message. My computer is telling me, good morning, Dr. Gabriel. All right, so anytime you see one of these blue boxes in the notes, I want you to pause the video or pause your reading, go over to RStudio and actually do what it says for you to do. And please, here, this is important. This is very, very important. Do not simply copy and paste code, all right? You need to get your fingers used to typing on the keyboard, all right? It's a lot of times when we copy and paste code, we can inadvertently induce errors or introduce errors. and we're not, it's more difficult for us to find where the errors are than if we had spent the time practicing and training our fingers to type appropriately. Okay, so at its most basic function, R is a calculator. So if I wanted to find out, so I'm what about 35 years old? So if I wanted to find out how many months that is, I could do 35 times 12. So I've got the multiplication symbol here, and R will calculate that I am 420 months old. That's nice. So so we can use R for all sorts of arithmetic here. So and I think there's a table of arithmetic. Yeah. Okay. So these are the table of logical comparisons, which we're not there yet. So this is multiplication, and then we've got division. If I say, okay, well, I want to go back, so I'm 420, and I think I'm like 9 months along into my 35th year. So that's 420 plus 9. So that's 429 months. And notice on the keyboard, I can press the up arrow on my keyboard, and that will recall the last line of code that I ran. And I want to find out my decimal age. So then I would divide this. So here's the division symbol, this backslash or the slash right here. Divide this by 12, and I am 35 and 3/4 year old, something along those lines. Now, obviously, I don't need a computer to do 9 divided by 12 and find out that it's 3/4, but just kind of go with it for the time being. So we've got addition, we've got multiplication, we've got division, and subtraction is what you think it is, 10 minus 9. And then exponentiation. So if I go 2 to the 6th power, I get my 64-bit computer or something along those lines. So that would be 2 raised to the 6th power. This is my up caret key, my exponent. Now, if I want to clear all of this out, I want to get rid of this code. Now this is dangerous, so I'm going to pause here. Don't do this right now. Don't do this right now. I want you to hang on to all of this code for a little while. But I can do Control L. So you don't do this, but I can do Control L on my keyboard, and it's going to give me a fresh, clean console. And if you're worried, you say, "Oh, well, how do I? Oh no, I wanted to keep some of those computations." Over here in the History tab, it shows all of the code that I've run. So I want to pause right here. This is very important. Do not rely on the History tab. Do not rely on what is in your console. We're not going to write any important code yet. But once we do start writing important code, we're going to learn how to use something called a script so that we can save our work and share it with other people. So this is where we will pause for now. We'll pick this back up with logic next video.